So this one, it's a little different here. And what I'm seeing at this point is I do need a principle of equality. And the reason I know that is because there's no combining like terms on the left or the right. And there's no parentheses, so I know there's no distribution either. Maybe I should have did that in the other order. There's no distribution, then there's no combining like terms. So I am expecting to jump straight into principles of equality here. But what you may find that's different about this problem is that there's x's on both sides of the equal sign. That's new to us for this class. But remember, we can use principles of equality to force even x terms to become zeros. So here's what I do is I say, just from the beginning here, I'm going to put my x terms, I would just like my x terms to be on the left, and then I would like my constants, I'm going to use the, I know people today say that's a hashtag, but it's a number symbol for my generation. So here's what I'm going to do. I'm going to analyze this just based on what I just did there. I want x's on the left, constants on the right. So I start with my first term, negative 3x. It has an x term. It's on the x side of things. That's okay. Checks off. It is where it should be. What I don't want is this negative 14 on the x side of things because it's not an x term. It's a constant, negative 14. So right off the bat there, I see that I need to zero out that negative 14 by adding 14. But it is a principle of equality, so I need to do it to both sides. Now on the right side, you'll see that I put this beneath the negative 2. I would not want to put it beneath the negative 7x because I'm not combining it with the negative 7x. The negative 7x is an x term. 14 is a constant. I need to combine that with another constant on the right side. So here's what happens is my negative 3x, I take it and I drop it. Just as usual, I have the negative 14 plus 14, which zeroes out. And that was part of the plan there because it was a constant on the x side of things. That's no good. The negative 7x I will also drop because I didn't combine it with anything. And then I have negative 2 plus 14, which I just put in the calculator, and it gives me positive 12 now. So this is my new equation, but again, even this equation looks different. What I mean by that is if you had started with just this equation, you may have been like, what the crap do I do? Well, we just did the one step. We can work with this one as well. And it's the same idea. Here I just want, so the negative 3x, it's on the x side of things. That's good. The negative 7x, though, is on the constants, the number side of things. That's no good. So I need to zero it out. And yes, I'm not addressing the 12 because I'm just doing this one term at a time. So the negative 7x there, it needs to go away. It needs to become a 0. How do you make a negative 7x a 0? Just add it to itself. The same way you would with constants, but now it has an x with it. But yes, if you do it to one side, please do it to the other side as well. So negative 3x's plus 7x's would be positive 4x's. In the calculator, you would just type in negative 3 plus 7. Negative 7x's plus 7x's, that zeroes out just as we planned and we wanted to happen. So it did exactly what we wanted, and then the 12 can be dropped. Now this equation should look more familiar because I need only one last principle of equality to solve this to make my coefficient a 1. And I'll do that by taking the 4 coefficient and dividing it by itself because anything divided by itself is 1. Then on the right side, 12 divided by 4 is 3. So in checking this, I've got to check it twice in the calculator. The first I'm going to do on the left, I'm replacing the x with 3, but both x's with 3. But again, I'm just going to do this one at a time. On the left side, I've got negative 3 times 3 minus 14. Enter. And on the left side of the equal sign, I get this negative 23. So I am checking for truthfulness. On the right side, I've got negative 7 times 3 minus 2. Enter. And on the right side, I also get negative 23. Negative 23 does equal negative 23. This is a true statement, which means I now know that I have, in fact, found the solution. But again, the thing that may differ from what we did in 7th and 8th grade is I'm using the calculator to check this. I'm not actually even showing the work for it other than to just up here replace the x's with 3's and just check for truthfulness.